In the next two examples, we want to look at how we can use Wolfram Alpha to find vertices and intercepts and how those points can tell us some practical information about a problem. In example 7, with a ticket price of $25.09, the average attendance at a soccer stadium has been 40,973. When the price dropped to $13.09, the average attendance rose to 77,389. Assuming that attendance is linearly related to ticket price, we want to use Wolfram Alpha to find the price demand function with attendance x as the independent variable. That means we're going to flip over to Wolfram Alpha and ask it for a line through 40,973, comma 25.09, and 77,389, comma 13.09. So we're using attendance as the x variable, price as the y variable. And we generate that equation in slope-intercept form. Rounding a little bit, we can round this off to p of x. So we're generating a price demand function with lowercase p, negative 0.00033x plus 38.5916. From there, we want to find the revenue function, keeping in mind that revenue is price times demand. So we take x times our price demand function, p of x, to get negative 0.00033x squared plus 38.5916x. Now we want to use Wolfram Alpha to find the vertex of the revenue function, and then in part D, we'll interpret what that value is telling us. In order to find a vertex, we can ask Wolfram Alpha to optimize a function. What it's going to do then is search for the minimum and maximum values that occur. This is handy even though we're talking about finding a vertex, because the same command will apply to any other type of function versus just quadratic functions. So we want to optimize this given function, or this function that we found. We get some information that doesn't immediately make sense, but if we click on that approximate forms option, it's going to tell us that our maximum occurs at an x value of 58,472 and a y value of 1,128,266. That's our vertex then, that x and y pair. And in part D, we want to interpret that information. We know that our value for a, in this case, is less than 0. So our quadratic function is opening downward. That parabola is opening downward. That makes this a maximum. The vertex tells us that the maximum revenue of $1,128,266 will be achieved when they sell 58,472 tickets per game. So what we found was the optimal number of tickets to sell and the optimal revenue that will result from those sales. Then in part E, we want to find the optimal price point for this product. For ticket sales. We want to take that 58,472 because that's our optimal number of tickets to sell, and plug that into our price demand function. Since that function relates number of tickets sold to price, when we evaluate that price demand function at this x value, then we'll get the optimal price point. Oh, I'm sorry. That shouldn't be. I was plugging that into the revenue function. We want to plug it just into the price demand function. Which we could do with Wolfram Alpha or a basic calculator. And we would get approximately $19.30 as the optimal price point that would yield this number of tickets sold and generate that optimal revenue that we found.